Why does this particular thing have an S on the end? Alcohols. Because there's a whole class. So when we call something alcohol, it's a whole class of compounds. It's a whole group situation. It's not just one particular thing. It is specifically as far as chemical is concerned, it's called a hydroxyl group. And that's a fancy word, but as you can see, it follows all of our normal naming conventions. When we have groups added to it, we have that little YL, ul ending. And this is particular. What kind of thing? You could probably look down below and see what it is. It's an OH stuck to the end of something. So an OH is our hydroxyl group, hydroxide, hydroxyl group. So these are hydroxides, and they're stuck to a large hydrocarbon chain. So that's what an alcohol is. It's very simple. When we're talking chemically, alcohols are hydrocarbons with an OH group on it. That's all. That's what the class of alcohols happen to be. Alcohols have some interesting properties that are different than than most other hydrocarbons. The properties of alcohols is these are polar molecules. Do you guys know what a polar molecule is? It has nothing to do with the Arctic. So we'll just leave this here until we get to that lesson. We'll get to a lesson on how polar, what that means for molecules. It means a whole thing, but I think it's in a later chapter. So we'll get to that later. I can. Polar means one side's different than the other. It has to do with charge, yes. It has to do with electrons. So it's chemistry. It has this great word, miscible, in water. Miscible. You got me all combobulated there. Miscible. I told you what miscible was during the density lesson, I think. I said the word miscible in it. Does anyone remember what that means? Nothing. Okay, great. So miscible means it can mix. It mixes well. It makes solutions. So it dissolves in water. So it can mix in. Because normally, all the hydrocarbons we've worked with, such as like propane or gasoline, they don't mix with water very good at all. So alcohols do mix with water rather well. They can show up at the end. Oops. Spelling. The end or in the middle of the molecule. So it can go on the end or it can go in the middle, anywhere that group can go. It can occur more than once. We can have multiple hydroxyl groups on a chemical. So we can have OHs more than one place. So can occur more than once in a molecule. Oxygen supersedes the numbering on the chain. So this is another step where this group resets the numbering system. So whichever carbon supersedes, I got to put the S on that for grammatical correct now. So supersedes the numbering chain. So even over double and triple bonds, where the oxygen is will be like, that's how you set the numbering, is to make the oxygen the lowest number it can be. So whichever way you have to number the chain, you make the oxygen carbon, like the carbon that the oxygen is stuck to, the lowest number it can be. It doesn't have to be 1, but it has to be the lowest number possible based on what other pieces are in it. Yes, and I say it out loud, but even over double and triple bonds. Because those were the last things that I introduced that supersede the naming, is we number the molecule so that the double bond has the lowest number possible, but now we have to number it so the oxygen the hydroxyl group will have the lowest number possible. They overdo a lot of the naming. So I'm going to draw you a few particular examples of alcohols here. You will see the thing in common with all of these words. What do you see in common with all the words? All. So it's this all ending is the alcohol part. So it has this O-L ending. So when it ends in all, that means there's an alcohol, there's an OH group in this molecule. So it's this all ending. So an ethanol, how many carbons do you think ethanol might have? 2 carbons. So a simple 2-carbon chain, I'll draw it structurally here, and we'll just put OH on one side. That's it. That'll do it. That's ethanol. Propanol. And specifically, propanol has to be given a number. 1 propanol will look like this. Now I'm going to start doing line diagrams because they're lazy. Go 1, 2, 3 in the chain, and then we draw OH here. So when we're counting our carbons, we got a carbon here, a carbon here, a carbon here, and the OH is stuck on the end. In this case, it's numbered from the beginning. Now, we can put this the hydroxyl group here in the middle, and we'll draw that here. So if I draw it like this, that's a different thing. This is 2-propanol. We'll get to that. We have 1 propanol and 2 propanol. Have you heard this word before? No? Never heard of propanol before? What about if I change the 2 to isopropanol? Yeah, what's that? It's rubbing alcohol. So isopropanol, which is this particular thing, isopropanol, is the rubbing alcohol that you can buy at a store. The reason it's called iso means like the same, like isosceles triangle. It's like the same on both sides. So because the OH group is in the middle, it gets the word iso. That's a common naming convention, not a rules-based naming convention. Proper name is 2-propanol, but we have a lot of common names that show up here and there. When we're asking for names, we're always asking for the proper names. Butanol has 2 varieties. Let's see if we can do both of those. 1, 2, 3, 4, then an OH group. That's 1-butanol. And then we can do 1, 2, 3, 4, and I can put the OH there and get 2-butanol. Can I make 3-butanol? Why not?
It'd be the same as
It's the same as 2-butanol. I gotta really slow down when I'm saying these words. So you just have 2 varieties of the butanol because they're in the 2 different carbons. That's on carbon 1 and this one's on carbon 2. That's the difference. So you can either stick the OH on the first carbon, stick the OH on the second carbon. Clear enough so far? Well, we haven't got things too messed up yet. Okay, let's give you some ugly pictures to try to name. Let's name these particular alcohols. So we notice our OH group is here, so we have to number it so that we keep the numbers the smallest. Which carbon is this one here? It's 3. Now, does it matter which side I go on? Kind of. But not for the OH. It's 1, 2, 3 this way or 1, 2, 3 that way. So that doesn't matter. But now we'll choose the direction to keep these with the smallest number. So we're going to number from this side. So I'll just add the numbers in for us because I like to show what I'm thinking. 1, then 2, then 3, then 4, then 5. Those are my 5 carbons in this chain. I have my OH is on 3, and I have 2 chlorines on 1 and 2. So what should I start my name with? The chlorines or the OH? So we're going to start our word, like the OH is our parent. So that's going to actually show up at the end of the name. We use it to set the priority first, but we tend to when we're looking at a drawing versus a name, they're kind of reversed. The end of the name is the parent, and the beginning of the name is all the groups that are attached to it. So the groups attached to it, we're going to start with the chlorines on 1 and 2. So I heard it out loud. It was good. It's 1, 2, dichloro, 3, pentanol. So that's all the things that we got here. We have our 1 and 2 chlorines on here, and the pentanol is on 3. So it's 1, 2 dichloro, 3 pentanol. All right. The next lovely picture, we have this ugly thing. We got triple bonds. What word does that show up as? That's an ine, right? So we have an ine and all. So it's a whole bunch of stuff in here. So we can have double bonds in our alcohols. It's totally fine. So it's getting busy. We're adding a little piece at a time. So let's take a look. We know we're going to have to start numbering here. So OH is going to be stuck to this one. So that's going to be a 1, a 2, a 3, a 4, and a 5 there. So those are my 5 carbons in this case. And then I have to say where my stuff is. So now we always number backwards. So we have this thing, our ine is on carbon 3, and this thing's on carbon 1. So I think the best way of naming this is actually 3, 1 pentanol. It's a whole mess here. So let me see if I can label this better. I should probably clean this up here. And I'm just going to, it's the same, but I'm just going to change colors so if anyone has to try to read this later, it might make more sense. So the OH gives me this all ending, and that's going to be the 1, right? The 1 is the green, and that's on the end. And the purpley one here on my screen, that's the ine part, and that's the 3. And since the ine comes before the all, the 3 has to come before the 1. So the 3 is telling me where the triple bond is, and the 1 is telling me where the alcohol is. Does that kind of make the sense for the order? We have the 3 is telling me where the pentyne is. That's this here. And then the 1 is telling me where the all is. So the double bonds come before the alcohols in the name, because the alcohol, it always starts with most important at the end. We go backwards. So the most important thing in this molecule is the alcohol, so it's at the back. Next most important thing, triple bond, that's next. And so that's the order. Now there's also this other way of writing it, which I'll just kind of show you as well. It's 1,000% worse than this, but it is also a little bit easier. It's easier to read, but nearly impossible to say. It looks like this. It is pent 3 ine 1 all. Not awful. That's also a correct way of writing it, but that's impossible to say. Not bad to read, but it's terrible. Like pent 3 ine 1 all. Ooh, that's awful. I like 3 1 pentinol. I like that one better. So I like this one less good, but still true. They're correct. It is correct, but you'd have a hard time trying to describe to someone what that is. But if it's on a label, you'd be like, okay, I know what this is. So the goal is clarity, not necessarily language-based. Stretch all of my drawing things. We're going to draw some alcohols. Just 3 examples, and that's the end, because really this whole topic is just on alcohols. So we have 2,4-pentanediol. So let me try to pull a whole bunch of things here. So the first thing we want to notice here is this ending here. It's called diol. What do you think that might be? 2 OH groups. Where would they be? 2 and 4. Right? They match. So this is, I'll write it as a description. 2 OHs on 2 and 4. That's what that means there. And then the next rest of the word is pentan. So that's showing me an ane, right? So it's a regular 5-carbon, no double bond kind of chain. So it's a 5-carbon chain. And I'll write singles. So it's 5-carbon, all singles, no double bonds. So it's a 5-carbon chain with 2 alcohols on 2 and 4. That's how we decipher it. Now we'll try to draw it. I like to use line diagrams because I'm lazy. 2, 3, 4, 5. So I got my 5-pentane here. And then on 2 and 4, I will put OH, and I'll put OH there. So this is my 2,4-pentanediol. Good? Oh, done. Just did them all. Bold choices. But there's lots of room if you have to make a change. There should be okay. You should, given the rules I've told you already, you probably can do all this, but this is a good example. All right, so let's figure out the end. How many alcohols do I have? 1 OH, right? It's just hexanol, right? So I have 1 OH group. That's all that's there. So 1 OH. That's it. What is this next word that I've got here? I'm going to make it red because I think it's the most important part. Cyclohexane. What is that telling me?
It's a circle.
It's a circle? A 6-cycle with a double bond. Where's the double bond?
On the 2.
Double on 2. Good. That's all the words we needed there. So it's a cyclohexene with the doubles on 2. Normally the double would start on 1, but what's messing with the double being on 1? The alcohol. The alcohol's making that carbon 1, and then so the double bond is 1 away from that, so the double bond is now on 2. And then we have our last little bit of things to add. We have a methyl group stuck on 5. So a methyl, 1 methyl. Oops, not methyl. On carbon 5. So we'll start this by just drawing a straight hexagon, I think is the best way to start this. Get a nice hexagon here. Big enough, but not too big. You know we're going to add some stuff to it, so give it some space around it. So I've got a nice hexagon here. And then I've got to pick a side and put my O on it somewhere. I'm going to put my O on it right at the top here. It's a circle, so it doesn't matter which one, where you draw it. And then now I've drawn my OH, I can now start my numbering system. So I'm going to use the clockwise. Doesn't matter because the molecule can flip over. But I'm going to start measuring or counting around the circle. So this is now carbon 1, that's carbon 2, carbon 3, carbon 4, carbon 5, and carbon 6. So those are the 6 carbons around the circle. It doesn't matter which one we use. Where does my double bond start? What is it between? It's between 2 and 3. So my double bond is going to be, oops, I want it back to blue. So the double bond is going to be over here in my particular diagram. So I've got my double bond here. And then where is my methyl group? It's over here on 5. So that's CH3. I drew it backwards. Oh well. So that's fine. My methyl group is there. Now, in a line diagram, I don't have to write the CH3 on there. I could just leave it as this. This is also true because that one line out is a methyl group. That's also fine. So you can put the CH3 on the end of it as a description. It might be more useful if you have anything else stuck to that, but there's just a single methyl group. You can just use the line diagram there. That can stay like that. And that's this methyl group is this one here. That's the methyl group. So we have an OH on 1. We have a double bond on 5. Two I's on 3 and 4. 2 F's on 2 and 2. And it's a circle 8 carbon. So we have a circle 8 and this many things on it. Great. Let's draw a big octagon. And we got lots of space here, so I'm going to draw a reasonably large octagon here so it's easy to see. Because sometimes these can get small and it's hard to see, but I want to try to draw a reasonably... Oops, I don't like that color. I've got to go back to the base of blue colors. So, that's really long. Let's clean that up a bit. There we go. That's why you want to draw a lot of these things in pencil. Great. Now, we don't have to start anywhere in particular. To follow my last year's picture, I'm going to start there. And the basic reason I want to start with somewhere on the right-hand side is so the O is first and the H is second. If I put my OH on somewhere on the left-hand side, it has to be H, then O, because that's the way bonding works. So now I can start my numbering, because I know it's 1, 2, 3, 4, 5, 6. 7. Oops, erased. 7, 8. So you don't have to include the numbers when you're drawing it. It's just a guide. So I'm putting the numbers on the diagram so you guys can see what I'm thinking. The double bond is next. It goes between 5 and 6. So this is my double bond right here. I can put it on the inside or the outside. It doesn't really matter. I drew my numbers on the inside, so that's where my double bond's going to go. If not, like a correct way there. Iodos on 3 and 4, so I can put my I's on 3 and 4. And then I put F's both on 2. Then I got a circle with an ene on 5, with an hydroxyl group on 1. Yes, I think I have finished. Any questions? Happy? All right. All right, that's the homework there. And I'll slide down just for a quick second. Already done. So it's really just this one. And they're not big anymore. I put them on 2 pages. I'll show you that in a second.